This gives a little more details of how these gliders are used. Really calling your attention to this graph here. This is crossing over a eddy that was present in the area, and these are elevated levels of chlorophyll fluorescence, and it indicates where some of the biological productivity is. Ocean models are often used along the coast. Francisco showed these beautiful animations over wide scales. When you begin to downscale these models, this is from the JPL team, you really need more and more subsurface observations to make those models work, and this is one of the benefits of where those gliders data feeds into it. Other applications of gliders, this is a group from USC conducting glider transects. Now we're looking in Southern California, Huntington Beach area down to Newport Beach, running these gliders here. And these colors here represent the chlorophyll. And you can see the subsurface chlorophyll maximum and then coming up to surface. And they're beginning to use these gliders now as a surveillance tool to monitor the subsurface, where the subsurface chlorophyll maximum is located along the coast. And this is relevant because of the formation of red tides. I won't call them harmful because just being able to guess when a red tide gets initiated is a challenge enough. Of course, when they trigger to harmful, has a number of repercussions at a management level. These are surveys of domoic acid, and in this area you can see the high levels of domoic acid near the coast in units of milligrams per liter. Just take-home message, red spots, lots of domoic acid. Looking at time series of these domoic acid readings now from 06 up through the 07, you can see that the stranding numbers of marine mammals and birds are certainly consistent with these elevated levels of both the phytoplankton, as it could be measured by a glider, as well as domoic acid, which I don't believe there's a domoic acid sensor yet that could ride on a robot, but things that we can measure. So again, looking at correlations of what we can measure and being able to put together consistent stories. Right now, this has sort of evolved now to what we'll call a harmful algal bloom surveillance program, taking advantage of groups along the coast here. These sites now are monitored a few times a week, looking for, first doing the speciation of what's in the water, and then if potentially harmful producing species are there in some numbers, they'll do the more expensive sampling for the presence of the toxins. But it is a surveillance system that's now beginning to tell us what are those scales of harmful algal blooms and algal blooms along the coastline. So really this is it's been underway for about a year now. Another tool we use is HF radar. This is a number of those in the audience have been involved in making HF radar observations. Each one of these little green dots represents a radar station along the coast. This is the entire west coast, and 5 years ago this would be maybe a few little patches of where we had data, and otherwise it hadn't existed. If you were to zoom in at one individual location, you could see the types of data that are provided. These are hourly data of ocean surface currents that can be provided at various resolutions from 1 kilometer up to 6 kilometers, depending on what frequency of radar is used and how far offshore you want to work. This capability, in California at least, was funded through the State Water Board and the State Coastal Conservancy through proposition funding. So this was sort of the pipe dream we had several years ago, and you can see where we've come now, actually being able to realize that.